Greetings, I'm Professor K, and in this short video presentation, we'll be doing a memory analysis using the Volatility Framework. And in this lab, we will use the Volatility Framework to analyze a memory dump captured from a Windows XP machine infected with malware known as Crydex. For this lab demonstration, I will be using CSI Linux, though Kali Linux could also be used. The steps in the lab are the same regardless. So the first thing we want to do is just go ahead and make a folder that we can work in. To do this, I'm just going to right click on my desktop here. I'm going to select Create Folder, and I'm going to call this memdump. Just like that. Go ahead and create. Leave that there, and let's go on up to our Linux Quick Launch. And from here, we're going to launch our web browser. In the address bar, I'm going to input the address for the open source location for different memory samples. Go ahead and hit enter. Now once you're on the site, just scroll on down until you come to the option to download the malware-Crydex sample. Just go ahead and double click it. And it downloads very quickly. The next thing you want to do is just go on over here to your preferences, open that up, and from your preferences, select to view your downloads. And from your downloads, you're going to see that you have downloaded the memory dump, but we need to go ahead and keep it. So go ahead and select that option to keep. Then it's going to ask you one more time. You're going to say keep anyway. And now you can show in folder. Now once you have the memory dump in the download folder available to you, just right click on it. And from the context menu, you're going to select the option to extract to. From here, you're going to select the location for your desktop. And then from there, you're going to select the location for that new directory we've created called memdump. Just go ahead and double click that or open it up. And then scroll on down over here to the bottom right and click on the button that says extract. Once you've done that, you can close out everything, return to your desktop. Now what you can do is right click on that directory we created earlier called memdumps. Just right click on it and you're going to select open terminal here. Let's go ahead and make that full screen. To launch our Volatility Framework, at the prompt, I'm just going to type in the letters V-O-L, and then I'm going to hit my Tab key one time, and that's going to give me the options that I can choose from that are available to me to complete the spelling of the tool that I need to access. In this case, it's volatility, so now I'm just going to add an A. And now I'm going to press Tab one more time, and the command is completed. Once I have the name for volatility at the prompt, I'm just going to finish off the command by pasting the following: -F, which stands for use the following file, and the file I want to use is crydex.vmem, and space image info. So we want to get as much information about this memory dump that we're going to analyze as we possibly can. In this case, I want to establish where the memory dump came from and any other information I can have that will help fill out the profile. I'm going to go ahead and hit enter. And in just a moment, it comes back with the determination of the profile from which our memory dump came from. Now in this case, we're looking at a Windows XP machine with Service Pack 2. So for most of the remainder of the lab, I will be just bringing up the previous command with my up arrow, and I will be putting in another plugin. Image info, for example, is a plugin that is used with the Volatility Framework, and that's what we're going to be replacing as we go through this lab is the plugin. So I've got my command all established here, and I've typed in volatility, again, -F for use the following file. But I've also added the profile. And so I want the profile that is going to be used against this memory dump so that it can find the information that we're looking for. So I've typed in --profile equals, that's just the name of the profile that volatility believes belongs to our memory dump. Give it a space, and the first thing we want to look at is the process list. So I've typed in PS list. Go ahead and hit enter. And so you can see at the time that this memory dump was captured, all the processes that were running on this Windows XP machine. And as you scroll through this list of processes, you have to be aware of any that catch your attention. Some of these are just going to be normal processes that are going to run, and that's just the way Windows operating system functions. But when we see processes that are running, such as Explorer and an unknown processor called reader_sl.exe, these are the processes that you need to give your attention to. I've cleared my screen. And another plugin that we can use to view the processes running on our Windows XP machine is PS-Tree. Go ahead and run that real quick. Now you'll notice there's something peculiar here, and you got to take a look at it. It's that this root process right here for Explorer has another process running just beneath it called the reader_sl.exe. Let's go ahead and clear our screen. One way we can determine if something may be malicious on our computer when we're doing this memory scan is to see if there's any processes that are currently trying to hide. So to do this, I've typed in psxview, and this will show us any processes that are trying to hide and not be discovered. Now we have to look at the first two columns, the PS list and the PS scan. If any of those register as false, then that process is attempting to hide. In our case, we don't see anything that tells us that any process is currently trying to hide from our view. I'm going to go ahead and clear my screen. Now that we have identified our running processes, we can next check for any running sockets and open connections. To do this, we will call upon three different volatility plugins: ConScan, NetScan, and Sockets. Now the first plugin we're going to run is the ConScan. Go ahead and hit enter with that. Give it a moment. And it comes up and it tells us that during this processing of capturing this memory dump, there were two connections that were currently running using the PID of 1484. We next want to look at any running sockets that are currently available during the capture of this memory dump. So I've just replaced the plugin ConScan with the plugin Sockets. I'm going to go ahead and hit enter. And it comes back and it shows us all of the sockets that are currently running and what process ID is currently involved. And so what draws our attention here to the sockets is the one that is using process ID of 1484, running on port 1038 using TCP. We can attempt to run the NetScan module against this memory dump, but the problem we're going to run into is that this profile is too new and the memory dump is probably too old, and therefore it probably won't work. And it comes back that this command does not support the profile of a Windows XP machine running Service Pack 2. Let's go ahead and clear our screen. And now we're going to switch on over to three other plugins that we need to run across this memory dump. And the first one is going to be command line. We want to see what commands were ran from the CLI on this particular memory dump. So let's take a look at that real quick. So far we know that the Explorer.exe with a process ID of 1484, we see that right here in the command line, is directly associated with the process ID 1640, which is running the reader_sl.exe program. And we see that here. So now that we have identified a link between Explorer.exe and the reader_sl.exe and how they are associated with each other, and now that we have the complete path for how these two programs are actually being ran, we're starting to look at this reader_sl.exe with a little bit more scrutiny. So let's go ahead and clear our screen. Using the following command, I'm able to dump out the memory area that runs this executable up inside of this memory dump. And we can take a closer look at exactly what's going on behind this process of 1640 running the reader_sl.exe executable. Now what I'm telling it here to do is to dump out that part of the process from the memory dump and put it into the root directory. That's what the period does. And so with this first command, we created a dump of the executable called 1640 for lack of a better term, and we now have that up inside of our root folder. We next need to look at the addressable memory that was being utilized by the executable. So in this example, what we're doing is we're pulling out all the available information we can about the process ID 1640 that is running and is associated with that executable reader_sl.exe. Go ahead and hit enter. And so now we're hoping that we'll be able to look closer at what was going on inside of the memory where this reader_sl.exe was running. Now to do this, we're going to use a strings command that is pretty common inside of Linux. So I've typed in the following command: strings space the name of the file 1640.dmp, and that's the dump file that we just created. Whoops, I got to take out that $sign. Let me use my up arrow and let's get rid of that. Alright, let's get back up here to the front and we're going to hit enter. We used the crep command combined with the $C followed by the number to get the previous and next lines, thus giving us more context for the information that was found. Here we can clearly see that the executable reader_sl.exe is communicating towards the destination IP address of 41.168.5.140 using post request, potentially exfiltrating information from the victim's computer. Now this memory dump that we created for process ID 1640 has a lot of information going on inside of it, so we're going to have to go through it one page at a time. Now to do this, we can also use the strings command, and we're going to tell it what dump or what file we want it to look at, and we're going to give it a space, a pipe, and then we're going to use the less command. When we use the less command, we're saying show me the information one page at a time. So we're going to go ahead and hit enter, and we can scroll through this information one page at a time just by using our space bar on our keyboard. So there's another page, and we come down to this long list of banking URLs. So we've got a lot of suspicions going on here about this reader_sl.exe, but we need to confirm our suspicions by seeing if this is actually a piece of malware. Now to do this, we could either reverse engineer the executable, which none of us have the expertise to do, or we can just use an online website such as VirusTotal to examine it for us and give us back the information we're seeking. So let's just go ahead and minimize our terminal, and now we're going to go over here to our Linux quick launch, and we're going to launch a web browser. In the address bar of our browser, we're just going to tell it to go to virustotal.com, and we're going to hit enter. And once we're out here at the virustotal.com site, we're just going to make sure that we've got files selected, and then we're going to use the upload option. So go ahead and click on the upload option, click on your desktop, make sure you go into your working folder, which is memdumps, and find that executable that we created from our memory dump, and that was executable.1640.exe. Just go ahead and double click it, and in just a moment it comes back and it tells you that 32 out of 72 virus scanners found this to be malicious. So we have determined that the executable reader_sl.exe is a piece of malware, but what's launching it? That's the trick. So now we're going to delve into the registry and see if we can find out how this is being launched at startup. Let's go ahead and close out our browser. Let's bring back up our terminal. Now to get out of here, all I have to do is just press Q for quit, and I'm back to my prompt. So most malware will look to see if the infected files are still present at every system startup. Sophisticated malware will also communicate with the executable every few minutes to ensure that it is still present and it has not been removed. If it has been removed, they will rebuild the executable, but this time often they'll use a different name. If you remove the executable without removing the payload that rebuilds it each time it is cleaned from the machine, you just keep going in circles. Granted, oftentimes you can find a virus scanner that will find the executable and will remove it. But if it can't find it at startup and remove the actual payload that is regenerating the executable, then each and every time you launch that machine at startup, it's going to rebuild or replace that deleted malware that you took care of with your virus scanner. So to see what registry hives are present on our target machine that we're pulling this memory dump from, we can use the Hive list plugin. Go ahead and hit enter. And now we have our registry hives. But what we need to find is what is hiding in one of the keys that is running as an executable at startup, so that we can see what is actually launching that reader_sl.exe. All right, let's go ahead and clear our terminal. And this next command that we're going to run is going to allow us to look at a specific key. And we get that with the -K switch. And up inside of here, we're going to look for what is running at startup. So we're looking at the software, Microsoft, Windows, current version, run key. That's the one we want to analyze. So I'm going to go ahead and hit enter. So you got to take a look at what's actually running at startup. If it's a system service, well, that's normal. But if it's launching an executable, that may not be normal. So you got to take a closer look at that. Now to do this, we're going to scroll on down through the hives here and see if we can find anything that's going to give us some information about who or what may be launching this executable. And here we see a KB00207.877.exe that is being launched at startup under the profile of someone named Robert. And we see that this is up inside of the application data. That's where it's located. And the registry is telling it to launch this at each startup. There's our culprit right there. Let's go ahead and clear the screen. Now what we have to do is see if there's any association with that KB executable that we just discovered and our running process of 1640. If there's a link between the two, then we know we have found what is actually reloading that malware every time we delete it. We're going to pull this information out of the memory dump that we created for the process of 1640. So if anything is found in regard to that KB executable inside of the 1640, well then there's our link. And rather quickly we're shown that the executable KB00207.877.exe is directly associated with the process ID of 1640. So we're pretty certain now that the Crydex malware modified the startup registry to include the launching of this executable each time the machine started up. This should tell us how we can delete this executable, this malware, from the user's machine or any machine on the network that is currently infected with Crydex. And so that's going to conclude this short video presentation on how we go about performing memory analysis using the Volatility Framework. You got questions, you got concerns, don't hesitate to reach out and contact your instructor, and I'll see you in my next video.